Alright, so 1.5, we're talking about angle measures. First of all, okay, we all have a pretty good idea of what an angle looks like, right? I had some confusion yesterday. Some people were telling me that an angle is the same as a vertex. That is not true. Remember, we talked about a vertex not having any size, correct? Or a point, because a vertex is a point. And we talked about a point not having any size. Well, if a point doesn't have size, can the point be the same as an angle? No, because angles have measures, right? Okay. The vertex is where the two rays that make the angle connect. The angle is this part itself. Okay, so just be aware of that. Those are different. Anybody tell me a way to name this angle?
ABC.
Angle ABC. Could I also call it angle CBA?
Yes.
Could I call it BAC?
No.
Why?
It's not in order.
Not in order. And when you guys say order, you're saying in order because you know that B, the vertex, always is going to have to be that middle point, right? Okay? So your vertex is always going to have to be in the middle here. Now, you could also call this angle B. Okay, to save yourself some time. But I want you to be very careful with that because that doesn't work all the time. The reason it works right now is because how many angles are at point B? One, right? We don't count anything over 180. Okay? Right now there's only one. Okay? If I were to do this, now how many angles are there?
Two.
And there's actually kind of a hidden one. There's actually three. Okay? There's one here, and then you still have that big one. Okay, that big one is probably the one you guys didn't see. Okay, so there's actually three. Now I can't call that angle B anymore because if I say angle B, nobody's going to know which of the three I'm talking about. Does that make sense? So, in this case, I would have to use ABD, I would have to use DBC, and I'd have to use ABC. I'd have to use 3 letters for each one. Okay? So if there's more than one angle at any given vertex, you cannot name it with one letter. As long as there's only one angle, you're good though. Okay? Alright. Like I said, some of this I'm going to breeze through to try to give you as much time here. Afterwards, interior means, so this is the interior of the angle. Out here would be called the exterior. Okay, moving on, we should know how to measure on a protractor. What is an acute angle?
Less than 90 degrees.
Less than 90. Like that, right? That's an acute angle. What is a right angle?
More than 90, less than 360.
90.
It is 90.
Right angle. Right is exactly 90, right? Obtuse
That is 90.
is more than 90 but less than
180.
180. Because once you go past that 180 mark, now you've entered into, let me show you here. Hey, if I'm here and I keep going and I end up over here, now I've just ended up with another one less than 180 on the other side. Does that make sense? So our angles that we talk about only go to 180. What is a 180 degree angle called? It makes a line. It's called a straight angle. Okay. Alright, flipping over, still going fairly quick here for you guys. Next thing they want to talk about is congruent angles. And just like congruent segments, we could have congruent angles. If this is 26 degrees, for it to be congruent, this one must be 26 degrees. We can handle that, right? If this is angle A, this is angle B, and we could say that angle A is congruent to angle B. Okay, basically exactly like what we did with segments, but now instead of segments, we have angles. Okay. They might not tell you numbers. They might just show you this. Those are tick marks for angles. Are they still congruent to each other? Yes. Okay. Now are they congruent to each other? No, they have a different number of tick marks, say, okay, signifying that they are different measures. Questions on congruence? Again, not a lot different than segments, only difference is with angles now instead of segments. Alright, now this next part is one of the major parts out of this section. Okay, talking about angle addition postulate. Angle addition postulate hopefully reminds you of another postulate that we've already learned. Anybody? Segment addition. Okay, we have angle addition and we have segment addition. Okay, very similar things, basically the same ideas, just with different things. So for angle addition, if I go too fast, stop me, let me know. Okay, but I have this angle here, or multiple angles. What they're telling us is that angle ADB plus angle BDC is equal to angle ADC. You guys probably could have figured that out if I would have just started throwing numbers in there at you. You probably could have told me the measure of the larger angle if I gave you the two small ones, right? Okay, so you've used angle addition before, just like you've used segment addition. Okay, they just didn't actually name it for you. So if my red angle is 40 and my green angle is 20, then my blue angle must be 60. Are there going to be scenarios where they give you the large angle and one small angle and you have to subtract?
Yes.
Probably they did it with segments, right? Okay, so be prepared for that, and that will probably happen. Now, a little bit more difficult one, and hopefully it's not too difficult. I think you guys can handle it. They give me this, but now they put an expression in here. Could make it a little bit more challenging. But what is something I know about that diagram that I have marked? It's a 90-degree angle, right? That large angle is 90 degrees. So how can I solve for x then?
Put it equal to 90.
Put what equal to 90?
2x plus 2 plus x plus 1 equals 90.
Because when you look at this, you know that to make this right angle, I need both this angle and that angle, right? Okay, so, like you kind of said, 2x plus 2 plus x plus 1 equals 90. You suppose they're always going to be 90 degrees like that? No. Okay. Matter of fact, I know in your homework they don't mark it, they just tell you in the directions blank angle is 123 degrees, or blank angle is 96 degrees, or 93 degrees, or you know what I'm saying? They're not going to mark it. They just mark this one because it was exactly 90. Well, 2x and 1x is 3x, 2 and 1 is 3. When I subtract, I get 3x equals 87. 87 divided by 3, 3 into 8 is 2, 6, bring down your
29.
And I get a 9, so x is 29, right? Do you suppose sometimes they will ask you for an angle measure instead of the value of x? Yes, they will, okay? Just understand and be aware of that. Read your directions carefully. If they want an angle measure, you need to substitute that in and get the angle measure. Now, is that any any different than that.
No.
It's the exact same thing, right? Except that it's in an angle instead of on a segment. Okay? So it really is the exact same thing we learned in that other section with segment bisectors and stuff like that. It's all exactly the same. Segment addition. Except now we're doing it with angles. Would you still get x equals 29? Yes. Okay? So just understand that this is all really the same thing. We're just applying it to angles now instead of segments. Okay? Still doing okay? The next and last term we have is an angle bisector. What was a segment bisector?
Like a midpoint?
It went through the midpoint. It did.
It cut a segment in
But it cuts a segment in half, right? Okay, and it goes through the midpoint. An angle bisector then, let's do this actually. What do you suppose an angle bisector does?
cuts an angle.
Cuts an angle in half. So, if that blue ray is an angle bisector, agree or disagree that these two things have to be the same measure?
Agree.
Agree. Because if I'm cutting something in half, they have to be into two equal parts. So, if this is 20 degrees, what's the top angle?
20?
20 degrees. And they have to be the same. What's the whole thing?
40.
40 degrees. Okay, using a little angle addition also. Okay. This part seems really easy, but this is actually one of the most confused things or places where I see the most mistakes come test time is when they say that's an angle bisector, and there's two scenarios that I see mistakes on. That's an angle bisector, and then they mark this and they say this is 100 degrees, and they say find the other two angles. Well, first of all, this mistake comes from knowing that what is marked here, the big angle or one of the small ones?
The big angle.
See how I drew the line all the way?
Yep.
That means the big angle's marked. The most common mistake I see on this is people like, oh, this one is easy. That's 100, that's 100, this is 200. Done. Okay, just be careful. Yes, that initial 100 degrees is written in the bottom angle, right? But it's marked as the whole angle. Okay, they gotta write it somewhere. You gotta pay attention to the markings. Okay, so based on this information, if the whole thing is 100, what are each of the small ones?
50.
50 and 50. Okay. That's one of the mistakes I always see on angle bisectors. The other one is they do this and nobody knows how to solve it. Well, if they're angle bisectors, what do you know about those two expressions?
They're gonna be equal.
They have to be the same, right? They got to be equal. So I would set this up, 4x minus 1 equals 3x plus 2. And then I can solve for x, right? I'm not going to solve that one out because I don't know if it's going to work out nice because I just made it up. But you have to understand what a bisector means. It means the two parts are exactly the same. Okay. I know I went through that really fast. Are there any questions? It's a lot like that segment section, right? Okay. If you have questions, bring them to me on, I guess we have a long week, so bring them to me on Tuesday. Okay, that's the next day I'll see you guys is Tuesday. Bring me the questions on Tuesday if you have them, because I know we went through quickly. Okay, notice we do have a test coming up. We have one more section until test time. Okay, so we'll do one more section, and then we'll have a chapter review, and we'll take our test. Okay? Questions? Alright, the next thing I want you guys to do